Power. We all want it. We all need it. It not only lights our homes, but it drives our businesses. It strengthens our communities. It empowers us to make our own decisions. Today, we're giving power to more than 22,000 members. We're a homegrown, locally based cooperative that does something the big electric companies won't: give safe, affordable, and reliable power to rural communities. We're Tipmont REMC, and our members have the power.
So what we've got set up here today, we've basically made a real-life live line demo as to what people are really going to see in the field when they think about electric utility company. This is what we've got out in the field. So we've set up a little demo today, kind of to show you equipment, what you might see, and just go over some safety facts of what you need to know out in the field. So what we got here is we've put the protective gear that Ed and I are going to wear, or anybody that works in the utility industry is going to wear when we're out working on power lines. If we're up in a bucket or something like that, this is the gear that we're going to wear day-to-day safety-wise to help protect us from that stuff. So you got, obviously he has his hard hat on, down to his safety glasses. We now wear FR masks if we do have to get in a bucket together, because we can't be within 6 feet without a mask. So we do have masks that are FR, which is fire retardant, for all of our clothes that we have to wear. Down through that, he's obviously got rubber sleeves on here that go up to his shoulders and down to where his rubber gloves meet. And those are rubber gloves that we get tested to make sure that they don't have pinholes, small leaks, or anything like that. Even after they come from the testing facility, daily we check that stuff for small pinholes and we air test them just to ensure our safety, so that we go home from work the same way we came to work. Underneath all that, he has his bucket harness on here that we can attach to safety off in our bucket for when we fly it. And it is FR also, so if something ever did happen and there was a fire, it's not gonna burn to him. Underneath that, which you really can't see, they're different colors, but him and I have the same clothes on. I have an FR shirt on and FR jeans, and then we wear EH boots, which are electrical hazard boots, and that's part of our safety equipment that we have to wear. But like I said, he's FR from head to toe with EH boots on also. That is some of the small stuff that we wear every day in the bucket just to ensure our safety. And like I said, we take that very seriously, and we test all that stuff daily to make sure that it is still in good operational use. Like I said, just for our safety, to protect us when we work on things. So what we've done is we've set this demo up today as what generator backfeed would be like. So we've got a cord that's come from our transformer outside that powers our building, and we've ran it in here. We've brought it in to this transformer right here. So that transformer is what feeds most people's houses. Obviously all different sizes of them, depending on the load that's going to happen at a certain residence or business or thing like that. So it's wound, it's got windings in it that actually step down voltage from what's going to come in normally on the top side of this transformer at 7,200 volts. Is going to step it down to 120 volts phase to ground and 240 volts phase to phase. Is what a normal transformer would do, but like I said, we're going to treat this as backfeed. So we've brought it into the bottom and the secondary side, and we're going to treat that transformer to step up voltage. So we're actually going to step it up to about 6,000 volts, give or take, is what this line's actually going to produce today. It'll feed up through the top of this transformer, through the cutout that we have mounted here, and then out onto our line. So this line is what we would have as single phase power. This is going to be our primary phase, and this is going to be our primary neutral. And like I said, this is single phase. We have 3-phase applications that are out there in the real world, obviously, but for today we just use single phase. So it travels down through our phase of neutral here, and then this is what we call a breaker or reclosure, and it's a protective device that's going to protect our system and our overhead lines and transformers and things from anything. Trees, it's going to help clear trees off of lines. It's going to help with down power lines, and it's really a good source of protection for us to use. But it's going to travel through this device here, back out into some more overhead that we've run through here. And then this is another cutout that we've got here, and we mounted it. We'll get it to blow and show you how it actually works in a second, but this is something that you're going to see to sectionalize smaller pieces of line. And in the real life situation, it's going to protect a transformer like we've got down there for anything as far as if the transformer fails, it'll blow the fuse on that. If this sectional line would go down for, say, for a tree or a car wreck or just down line in general that falls down, it's going to blow this fuse here to open this sectional line to try to help us isolate what we've got. We'll go back through some more overhead that we've got down here, and it'll feed into the top of this cutout here and down into this smaller transformer. This is just used for what we use as like street lights and things like that at entrances to businesses, business parks. If we've got multiple lights in there, we'll use a smaller size transformer for that. That will only produce 120 volts on the secondary side. So now that I've explained what each piece of device is, we'll energize this demo that we've got now to get this light to turn on down at the end. So what he's doing there is he's taking this tested stick that we've got in a voltage indicator to test. So right now we're about 6,100 volts is what we've got on this primary line right here. And as you can see, that was a test for him. Our light bulb did come on. So now we've proven that obviously everything works. You kind of know a little bit about what each device is here. So now what we'll do is we've got a personal protective ground that we're going to use down there as basically a phase to ground contact, and basically make a short between those lines. We normally are going to use that personal protective ground as a means for us. So if we've got down power lines, we're going to get out there and we're going to get two sources of an open source. So we have to have two visual opens, or one visual open, and we use our protective ground. So when this fuse would blow, if this line was to go down, this personal protective ground that we've got, we have our open source here as our visual open in this cutout when it would blow, and this ground is going to be here. That's going to help protect against, like I said, against backfeed, which is what we've got set up here. If you have home installs of generators and people just want their lights on in a bad storm or something like that, and we're trying to work on lines, we're going to use that personal protective ground to protect all of us that are going to be working on it against that potential for backfeed voltage. You never know what the presence of backfeed voltage might be, but we've seen it upwards of to 9,000 volts, I'd give or take say. So there's always that presence, and we're going to use that ground to protect us against that. So what he's going to do is he's going to take that ground and make that short so that we can show how this fuse will actually operate. Clear. So he's created that phase to ground short. Our fuse operates. Like I said, this is a source that we're going to use for smaller downline devices that we need that are smaller protection from a breaker size. We're not going to hang a breaker everywhere, so we're going to sectionalize stuff with fuses to get them to operate that are going to be downline. Like I said, we use them on line stuff. We use them to protect all of our equipment as transformers and things like that. So he'll install a new door there. So now what he's done is he's put a solid door in there, taken that fuse link out that blew, and we put a solid door that'll hold up to about 300 amps. We put that in there to simulate here on this live line demo to get this breaker to operate. Normally we're going to use a solid door like that on tie line or a piece of sectionalizing. If we're going to try to sectionalize some line, we'll use a solid door like that because they can hold more amperage than just your normal standard fuse can hold. That breaker normally will take about 3 energized shots, and what happens is there's contacts in there that open and close. With that ground chain on there, it's going to open itself, and it'll try to close itself again, and try to open itself back up, try to close again. And it'll normally take 3 shots before it comes completely opened. It is a mechanical device, so just because that handle is down, doesn't mean that that breaker is de-energized or dead. The line down line from it could still be hot. Because like I said, it is a mechanical device, and we don't trust mechanical devices when we're working on it. So if we were going to work on something downline from this, even though that handle's open, we're going to take a jumper offline so that nothing can get past this breaker. We're also going to install that personal protective ground for our safety while we're working on it, because we always have to think of the presence of voltage from generator backfeed or any other random source of voltage that could come upon from anything that someone's got out there. Okay, so we got a ground chain on down there still. We'll show you the handle, and you can actually see it from this view of the handle actually dropping to show you when it does open and close, what actually happens when it does open and close. So as you can see right here, the handle did open, and that's how we know that something did happen on that line. When we get out there, that handle is supposed to drop. Like I've said before, this is a mechanical device. You cannot trust those mechanical devices. So when we get out there, if that handle didn't drop and we do know that line's de-energized, we can come back here and test for voltage to make sure that what we've got downline is truly opened. And then we know something didn't work right in that breaker. We need to take it completely out of service and change it out for our safety and everybody's safety to make sure that it does work properly. One thing that we obviously try to protect against is animals. So we do our part, not just for animals, obviously the public safety as well, but we do our part to try to make sure that we don't harm any animals or hurt any animals. Obviously, we can't prevent that 100%. It's part of nature, and there's nothing we can do against that. But what we can show you is what does happen when animals do get up into lines, what it looks like if you don't ever see it, and all you see is a squirrel laying on the ground at the base of your pole at your house when it does take it out. We can kind of simulate what we've done is we mounted this owl and we've tied it to the ground so that there's a piece of copper coming out of his mouth, and it's tied to the system neutral, which I don't know if you can see real well, but it comes out of his mouth and down right here and is attached to our system neutral. And we can show you what will happen when animals do get up in there and make that phase to ground contact.
It's hot.
As you can see, our light came on, so it is energized. Now, as you can see, it does make a pretty blue light, but that's what a phase to ground contact would look like. That's not something that you're only going to see on primary though. You could see a good sized ball of fire if you did get into some secondary voltage as well. So not only is 120, 240, that is dangerous, which is the presence that's at your house. That is dangerous still. That is live power lines that do feed your homes, your businesses, places that you go to have activities, food, anything like that. Those lines are still dangerous. So even though they're secondary voltages and they're stepped down from what we're going to work on overhead, they're still dangerous, and you can still build just as big a fire on secondary as you can as primary. So not only is our primary voltage extremely dangerous, so is our secondary. So if there's anything, down power lines is a really big thing. If you guys have down power lines or anything like that, don't hesitate to give us a call at our office or whatever system you live on. Don't hesitate to give them a call if something's not right or you do see down power lines, because just because it is laying on the ground does not mean that it's de-energized. It can lay on the ground and burn, and you'll never see a spark, you'll never smell anything, you'll never see anything, you'll never hear anything, and it can lay there and still be energized at full voltage just laying on the ground. So if there's down power lines anywhere, whether it be from a tree, act of nature, or a car accident, whatever happens and there's down power lines, do not go anywhere near them. Let us come out, let us take a look at them. Let us figure out what's going on before you do anything, but don't go close to them because you don't know if it's dead or not. We don't know if it's de-energized or not until we get there. So whatever you do, stay as far back as you can, because it's not worth getting close to that. If it is energized, you could have step potential that comes into play there. Just because it's laying on the ground doesn't mean that the ground around it's not energized also. Because of soil conditions and things like that, the ground around it in a circle, just like a ripple effect, could become energized, and 2 different feet at 2 different potentials could potentially be fatal. So please, whatever you do, if you have anything that's down power lines like that, give us a call immediately, and someone will be out there as soon as we possibly can to take care of anything that's a down power line or anything that's a hazard like that, because we want to take care of public safety, and we try to do our best to make sure public safety is taken care of, and we take that very seriously. The safety of you guys and the public and the safety of us is important to us, so we take that extremely to heart. So what we've done, we've taken that fuse out of that cutout there. What we've got here is we're going to simulate a hand. So if you had a hand that got up across this cutout, we're going to simulate it to show you what could happen as far as that goes, and get that light to turn back on.
It's hot.
And as you can see, he's got the light on behind him. So that's tracking down through that cutout, and you can see it burn, but it also energizes that light down there to show you that the human body can be a good conductor and will conduct across that.
It's off.
What you can't see here is there is some black marks on this. So what electricity is going to do is it's going to make an entrance and an exit. You can see small little burn marks here where it did make contact with the top of that. What electricity is going to do is not burn from the outside in, it's actually going to burn from the inside out. So if we did cut this hot dog open, the inside of it's going to look more like mush instead of what processed food normally looks like. As I said earlier, this is our live line demo that we set up just to kind of show you some of the small hazards that can be associated with power lines. Two big takeaways: obviously down power lines are extremely dangerous and the work that we do is extremely dangerous. So if there is ever down power lines or anything like that, please don't hesitate to give us a call or your nearest power provider, whoever that might be, to make sure that we can come to the scene and take care of it and do it safely and do it properly, as we are trained to take care of that in the correct way. I do appreciate your guys' time and coming and watching our live line demo that we provide from Tipmont REMC. Like I said, thanks for your time and hope this was educational for everybody.